So today we're just going to do some review of the geometric figures chapter, right? And we have a unit exam, or rather I should call it a chapter test tomorrow. We need to review that for today. Here we go. So we're going to do some structured review practice in preparation for that chapter test. I just want to remind you that this chapter covers just three things: the characteristics of triangles, the characteristics of quadrilaterals, and then the big one is regular polygons. You really have to know that one quite well. How today's going to work is it's going to be a you try, I go over type of lesson. So what I mean by that is I'm going to post a question. You'll give it a try, like you'll have to pause the video, give it a try, and then I'll go over it. You'll have to unpause the video and see how I went about this. It's important that you're actually following these steps because I want you to walk through these questions and make sure you're really actually independently understanding how to do them. Anyway, I'll stop wasting time. Here we go. Question 1, an equilateral triangle has side lengths of 8.4 centimeters. Find the height of this triangle to the nearest tenth. Pause the video here, give this one a try. Okay, so how we'd go about this one is, since it's an equilateral triangle, we know all of the side lengths are the same. So 8.4 centimeters down here, 8.4 centimeters over here, and 8.4 centimeters over here. Now, in order to find the height of this triangle, what that's really talking about is this measurement right here. And drawing it in as a dotted line hopefully illustrates a little bit more clearly what we're going to have to do here. We're looking for this height, so I'll call it h. Notice how along the bottom here it forms a right angle. That right angle is going to be important because that's going to allow us to use the concepts of right triangle trigonometry to solve for the missing pieces of this. Now you have some choices here. You can either understand that in this right triangle we're looking for this side and that this 8.4 is a hypotenuse, and that we can measure the side right here to be exactly half of 8.4, which would be 4.2. Now personally, this is the way I would go about doing this, because now that we know what this side is, and we know what this hypotenuse side is, we can solve for this side right here using Pythagoras. Another way you could do it is understanding that in an equilateral triangle, all of the corner angles are 60 degrees. And since you know this is 60 degrees, you're looking for this opposite side here, and you have the hypotenuse. Opposite and hypotenuse can be used in sine. I'll show you both methods. So the first method is the Pythagoras method. So under the Pythagoras method, here's how I would do this. I would say a squared is this side, so 4.2 squared, plus b squared, which is your height, so h squared, equals your hypotenuse, which is that 8.4 squared. Plug this in your calculator. 1 second, I gotta plug this into mine here now. I got 17.64 plus h squared equals 8.4 squared, which is 70.56. Now we just need to subtract this 17.64 over, so 17.64, take that away from the 70.56, and you're going to get h squared is equal to 52.92. But we're not quite done yet because we need to find what h is. Just square root both sides. And if you square root both sides, you're going to find that the answer, if I can get it here, hold on, that the answer to the nearest tenth should be 7.3 centimeters. So that triangle is 7.3 centimeters tall. Now I'll show you the other way of doing this. Again, you only have to choose one way or the other. So if you solve it the other way, good on you. But here's the other way I go about doing this. Again, we know in an equilateral triangle that all of the corner angles are the same, namely they're 60 degrees. And we're looking for the opposite side when we have the hypotenuse, so we have to use sine, because sine in SOHCAHTOA, sine is opposite over hypotenuse, and this is opposite, and this, the longest side across from your right angle, is your hypotenuse. Okay, so anyways, 60, or sine of 60 is going to equal your opposite side, which is h, divided by your hypotenuse, which is 8.4. If we want to find h, we just need to times by 8.4 on both sides. So 8.4 times by sine 60, and you have to just throw that in your calculator, 8.4 times sine 60. And what do you know? Since that's equal to h, you're going to find that h is equal to 7.3 centimeters. It's the same thing one way or another. Magical how that happens, isn't it? Anyway, so we're done on that one. We're good to go. Hopefully you're able to get that one. And if you're not able to get those questions, don't worry about it. Just make sure you email me or send me a remind or something. Just let me know what you're having trouble with, basically. All right, next one. A parallelogram has two angle measures of 79 degrees and 101 degrees. What are the measures of the other two angles? Pause the video here and give it a try. Okay, this one was a really cheap, sneaky question. Remember, a parallelogram is a shape that kind of looks like this, where you got two parallel sides here and two other parallel sides right here. Let's just say that this is your 79 degree angle and this is your 101 degree angle. Now, with how parallelograms work is the opposite angles are the same. So this angle up in the corner is also 79 degrees, and this angle down in this corner is also 101 degrees. So the answer to the question, you didn't even need to draw a picture. Kind of a sneaky question again, but the answer to the question is 79 degrees and 101 degrees. That's all. Hardly any work to that one. All right, let's move on. Question 3, the height of a trapezoid is 12 centimeters. The bottom base is 15 centimeters long and the top base is 10 centimeters long. Find the area of the trapezoid to the nearest tenth. You're going to want to use your formula sheet on this one. There's your hint on that one. Pause the video here, give it a try. All right, now I'm going to go over this one. So I have a formula sheet in front of me, and on the back page of the formula sheet, there is the formula for the area of a trapezoid. It says an area is equal to 1/2 times A plus B times by H. Now the picture on that is really, really important because it labels what all of those different things are. I'm just going to try to draw this. Trapezoids are always tough for me to draw. The picture shows that this side is A, this side is B, and then this right here is H. So in other words, it's your height. Okay. Good news is about this question is they gave us the height. So there's your H. The bottom base, which is A, was also given to us, and the top base, which in the formula is B, was also given to us. Since when you look at the formula, capital A, of course, is the area, but we have this one, we have this one, and we have this one, little checks there. That means we're good to go. We have everything we need to throw into this equation. So area is going to equal 1/2 times little a, which is 15, plus little b, which is 10, and then end the bracket, and then times by the height. Height I'm going to put in brackets of its own just to make it cleaner. So I'm going to times it by 12 out there. Notice by bed mass, you got to do the stuff that's in the brackets first, right? So A is going to equal 1/2. Stuff in the brackets right here, 15 plus 10 is 25, times by 12. So it's 1/2 times 25 times 12. Just throw that right in your calculator. It's all multiplication, so you can just go from left to right. 1/2 times 25 times 12. Oh, that's actually a really nice number. Never mind even the whole nearest tenth nonsense. I just threw that in there because I wasn't sure when I made this question. The answer is going to be 150. And since the units on that were centimeters and its area, it's going to be centimeters squared. Make sure you include your units there. Units are really important. I know they're often overlooked, but you need to include those units as well. So 150 centimeters squared because it's an area. If it was a volume of a three-dimensional shape, it'd be centimeters cubed. Okay, just make sure you understand those units. All right, next up, the total sum of interior angles of a polygon is only dependent on the number of sides, not on whether or not it's a regular polygon. So I never made that clear earlier. That's just my way of, blipping it to you right now, saying, yeah, even though we focus in on regular polygons where all the angles are the same, that rule about the total sum of interior angles works on all polygons, regardless of whether they're regular. So the angles could be different. Okay, so just keep that in mind. So you have a non-regular octagon. So it's still an octagon, still has 8 sides, but it's non-regular, which means not all the angles are the same measure. A non-regular octagon has angle measures of 112 degrees, 145 degrees, 138 degrees, 101 degrees, 92 degrees, 112 degrees, and 172 degrees. Find the measure of the final angle in that octagon. This one's a bit of a sneaky one. Pause the video here, give it a try. All right, so I'm going to go over this one. This one was a little sneaky. Notice that the sum for a polygon of all the interior angles is equal to 180 degrees times n minus 2, where n represents the number of sides in your polygon. So in this case, it's going to be 180 degrees times by 8 minus 2, because an octagon has 8 sides. That is going to give us 180 times 6, which is 1080 degrees. That is the sum of all the angles of an octagon. We know all 7 of the other sides, and we're looking for the 8th missing, sorry, I said sides. We know the other angles. We're looking for the 8th missing angle. That's what I'm trying to say here. How you can go about this is just take the total sum of all the angles and subtract all the individual angles away from it. So we're going to go 1080 minus 112 minus 145 minus 138 minus 101 minus 92 minus 112 minus 172. Longest part about this is going to be throwing it into a calculator, but let's go. I'm going to do this one at a time. I'm at 101 now. Now I'm at 92. Make sure you don't miss any numbers or anything because it's easy to screw this up. Whew, okay, after doing all that, you get a relatively big number here. So I'm just going to double check, make sure all these numbers are in there. Oh yeah, I guess they all are. What I got as an answer on this one is 208 degrees. That's quite a beefy angle on that one. That's like a reflex angle. That's like this. Holy smokes. It's going to be a really weird octagon. That's all I got to say. It's going to look like something like, you know, they're gonna like have like that jumping out of there or something. I don't know. It's gonna look really bizarre though, that's for sure. We don't need to worry about that. That's the answer one way or another. I'll put a box around it because we're proud of our answer. There you are. All right, moving on. Question 5. A regular polygon has a sum of interior angles of 1,800 degrees. How many sides does this polygon have? Pause the video here, give it a try. All right, so hopefully this one was a little bit more straightforward. Maybe not, though. Again, there's nothing wrong with that. Just make sure you're reaching out to me and asking for help if need be, because I can't tell over these videos. You know, you're just watching it several days after I recorded it. We know the sum of interior angles. It's 1,800 degrees. Well, remember the formula is sum equals 180 degrees times by n minus 2. We know the sum is 1,800. So 1,800 equals 180 times n minus 2. It's just a matter of working backwards and finding n. Now remember, to work backwards, in terms of algebra, you got to do BEDMAS backwards, right? So when you're working backwards, you have to do BEDMAS backwards, which means get rid of your subtraction and addition first. Don't get confused here though, because this is locked away in brackets. Notice you got to deal with brackets last when you're doing reverse BEDMAS. So you got to deal with this last. That kind of bumps us up to the division and multiplication part. We need to divide both sides by 180. So if you divide both sides by 180, 180's gone here now. Dividing by 180 here gives us 10 equals n minus 2. Now those brackets there are doing nothing now. It's just 10 is equal to n minus 2. So you might as well remove those brackets because they're not doing anything now. Now hopefully it's a little bit more clear. You just got to add 2 on both sides. N is therefore going to equal 12. This is going to be a 12-sided polygon. There you go. All right, I think we're done. Yes, we are. Wow, see, that was quick. I mean, 12 minutes, but then again, that's not counting the work you would have put in. Whatever, you know, it all evens out one way or another. So what I want you to do for practice is any remaining practice questions from Chapter 5 in your workbook, please give those a try. And be sure to be checking those answers. And if you can't check the answers, please reach out to me so I can help you out on that one. And again, your chapter test tomorrow is going to look the same as the other digital ones that we've had so far. It's all going to be on Google Forms. Yeah, and if you have any other questions, please let me know. Best of luck.